The capability to oversee a fleet of 100 unmanned autonomous vehicles is within the grasp of a single individual. Greetings and salutations to everyone. In today's video, we will be discussing the fascinating concept of a single individual effectively overseeing a swarm of 100 unmanned autonomous vehicles. Researchers at Oregon State University have made significant advancements in this area, conducting a 4-year project funded by the Defense Advanced Research Project Agency. During the project, swarms of up to 250 autonomous vehicles, including aerial drones and ground rovers, were deployed in urban environments where traditional communication methods are hindered by buildings. This groundbreaking research opens up possibilities for the efficient and cost-effective utilization of swarms in various fields, such as wildland firefighting, package delivery, and disaster response in urban settings. Without further delay, let us dive into our discussion. These findings mark a significant advancement in the efficient and cost-effective utilization of swarms for various purposes, including wildland firefighting, package delivery, and disaster response in urban settings. According to Julie A. Adams from the OSU College of Engineering, while delivery drones are not yet widely seen in the United States, there are companies that have already implemented them in other nations. The deployment of delivery drones on a large scale is a logical business move, but it necessitates the assignment of a single individual to oversee a substantial fleet of these drones. Although our research is not a definitive solution that guarantees complete success, it does mark the initial progress towards gathering more data that could ultimately support the development of such a system. The findings, which can be found in the publication Field Robotics, are a direct outcome of the Defense Advanced Research Project Agency's initiative called OFFSET, an abbreviation for Offensive Swarm-Enabled Tactics. Adams was a member of a collective that was awarded an OFFSET grant back in 2017. Over the span of 4 years, a team of researchers skillfully utilized large groups of autonomous vehicles, consisting of both aerial drones and ground rovers, to collect valuable data in urban environments characterized by towering structures that obstruct traditional communication methods. These swarms comprised of up to 250 vehicles, operated in military urban training sites, and have the capacity to significantly enhance the safety of both American soldiers and civilians. Adams played a crucial role as a co-principal investigator in one of the 2 teams responsible for developing the system infrastructure and integrating the efforts of other teams. These teams focused on various aspects such as swarm tactics, swarm autonomy, human swarm teaming, as well as conducting physical experiments and working in virtual environments. According to Adams, the Associate Director for Deployed Systems and Policy at OSU's Collaborative Robotics and Intelligent Systems Institute, the task involved incorporating commercially available technologies and constructing the necessary autonomy for them to be utilized by a singular individual referred to as the swarm commander. This endeavor also entailed the creation of the essential systems, software, and user interface for the swarm commander, enabling them to effortlessly deploy both ground and aerial systems. The team at Smart Information Flow Technologies worked together to create a virtual reality interface known as I3, which allows the commander to effectively control the swarm by providing high-level directions. According to Adams, the commanders did not personally operate each individual vehicle due to the sheer number of vehicles involved. It would be impossible for a single human to manage such a task. Instead, the concept is for the swarm commander to choose a strategy to be executed and make small modifications as necessary, similar to how a quarterback operates in the NFL. The empirical evidence provided by the skilled swarm commanders showed that a single human is capable of deploying these systems in urban settings, which has significant implications extending beyond the scope of this project. The Department of Defense combined armed collective training facilities served as the testing grounds for various experiments. These experiments consisted of multi-day field exercises that gradually incorporated more vehicles. Throughout the exercises, swarm commanders regularly reported on their workload and levels of stress and fatigue, providing updates every 10 minutes. In the ultimate field exercise, which involved over 100 vehicles, the commanders' workload levels were evaluated by utilizing physiological sensors. These sensors collected data that was then processed by an algorithm, allowing for the estimation of both sensory channel workload levels and overall workload. According to Adams, although the swarm commander's workload estimate did occasionally exceed the overload threshold, it was only for brief intervals. Despite facing challenging temperature and wind conditions, the commander consistently managed to successfully accomplish the missions. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.